So this is week 57 quiz, and number 9 says, right triangle ABC with AC equals 3 units, BC equals 4 units, and AB equals 5 units is rotated 90 degrees counterclockwise about M, the midpoint of side AB, to create a new right triangle A prime, B prime, C prime. What is the area of the shaded region where triangles A, B, C, and A prime, B prime, C prime overlap? Express your answer as a common fraction. So let's just draw a new picture here where we have a x with a coordinate plane, and we set C as the origin, and every unit is just 1. So then we see that this would become 3, 0, then 4, 0, and this is 0, 0. And so the midpoint would just be the average of the y value and the x value. So 3 over 2 would equal, because it's the midpoint, so we have that 3 over 2 would equal 1.5. So the first coordinate would be 1.5. Second one would be 4 over 2, which is 2. That's M. And so let's create a triangle here. Here. So from M to AC. And we have that this point would, let's say, be like N. And so we see that triangle A prime MN and triangle A prime B prime C prime are similar with scale ratio of 1 over 2, because M is also the midpoint of A prime B prime C prime, of A prime B prime. I mean. So we find that this is 1.5 and this is 3.5. This is 3, so we find that, because we find that those are similar, then that means the ratio of the lengths is also similar. So since A prime C prime is 3, then that means that A prime B prime is just 1.5. And same logic with MN. And that means that A prime is just 3.5, because you just do 1.5 plus 2 and 2 plus 1.5 from the different points. And now we can erase these because they're useless to us now. From this, we can also find what B prime would be using the same logic. And so M down to here, and M also horizontally like that, we find that B prime will equal to 1.5 minus 2 equals minus 0.5, and 2 minus 1.5 equals 0.5. So we find that B prime would equal to 0.5, negative 0.5, 0.5. Sorry, let me change that a bit. So just negative 0.5 and 0.5. And so now we can find what point E is because it's the intersection of the y-axis and B prime A prime. So we can find A prime B prime because we have 2 points, and we can find the equation of the line. So we know the slope would just be 3.5 minus 0.5 over 3.5 minus 0.5, which equals to 3 over 4. And we see that's a slope. So y equals 3 over 4x. And then we have to find the y-intercept, which is just if we have 3.5 and 3.5, and we try to reduce this value to 0, so 3.5 to 0, then that'd be just the amount that this would reduce by would just be 3 over 4, and this is equal to 9, 15, 10.5 over 4. And we would calculate 3.5 minus 10.5 over 4. So 14 minus 10.5 over 4. And we find that it becomes 3.5 over 4. Which is just equal to 7 over 8. So it's just plus 7 over 8 here. And now we have the equation of the line, so we just substitute. Or, well, no, we already found point E because it's just a y-intercept of the points. So we have this as 0, 7 over 8. Just write that. 7 over 8. And now let's divide here by m. Let's divide, let's draw m, a line down here. And so we see that if we just could find what point G would be, then we would have the, wait, no. So if we've just find that this trapezoid over here, this one, plus this triangle will just equal the thing we're trying to find. And so if we can find this part by just having MEC this minus the rectangle here. And so we already know this is 1.5. So we know that because it's just a straight drop down from M and the x coordinate is just 1.5, then this is just 1.5. And because the y coordinate of point E is 7 over 8, then we know that this is 7 over 8. Finally, we know that this is just 2 because the y coordinate of M is 2. So we have all the side lengths, 1.5, 7 over 8, and 2. So the area of the trapezoid would just be 2 plus 7 over 8 over 2 times 1.5, which just equals to 23 over 8 over 2 times 1.5 equals to 23 over 16 times 1.5. And this equals to 32, 369 over 32. And so the area of that trapezoid just 69 over 32. Subtract this rectangle over here. And the area of the rectangle is just 7 over 8 times 1.5, which is just 21 over 16. So 69 over 32 minus that will equal to 27 over 32. On the other hand, we'll just use similar triangles for this. And we know that this height right here, this is the one that I'm highlighting right there. That will just be 2 minus 1.5 because, you know, this part is just 1. This part is just 0. Oh, wait. This is not 7 over 8. This is 0.5. So then that means that this equals to, this means that this equals to 0.75, which is 3 over 4. So minus 3 over 4, 24, 69, 24, 45 over 32. So that equals 45 over 32. And so we know that this, the highlighted part here, that just equals to 1.5. Because, wait, here, because we have 2 minus 0.5, which is FC. And so using similar triangles, we find that this is 1.5 and this part is 4. Then we have 1.5 over 4 as the scale factor, which is also 3 over 8. And since we're trying to find the area, we have to square this. And we find that the scale factor for the area is just 9 over 64. And then we times 6 because that's what we're trying to find here. And then we cross 32, 27 over 32 as well. And so we find that this is not 45, this is 45 over 32. But the total area is just 45 over 32 plus 27 over 32, which equals to 72 over 32, which equals to 9 over 4. So that's our answer.